first cut. On the other end, I want to make sure that I hit offset. Alright, this is the basic programming of your Setworks on your sawmill. Just go into program mode, and you can scroll through using the next and previous keys right here. So to start out, it's low core 1, there's low core 2, 3, and 4. Now next is your high cores. High core 1, 2, 3, and 4. Sets are just the same way. There's your low side, 1, 2, 3, and 4. And here's your high side. So let's say we want to adjust core 1 on the low side. So we want to adjust it down to 3.5. It's at 3 5/8 now. So we'll go down and then hit the adjust button, 3.5. Now let's say we want to increase the core 1 high side. We'll scroll and we get to high core 1, and it's at 5.5. Now let's make it 5 5/8. Sets are the same way. So I want to adjust set 2 on the low side. Or set 1, 2. I want to go, I don't know, down to 1.25 inches. And I want to adjust my set 2 high side. I'll just scroll to it. 3/16. Curve is after sets. I can just hit my next key. I get curve. If I go past it and go back. This is how thick or how wide space the band blade takes out as it goes through the wood. You can adjust this up a little bit heavier than what the band is actually to get your lumber to be heavier. Let's say I want to adjust it up 5/1000, so I make sure this is in the up position and adjust. Next is my tear. This is adjusted by the computer at all times. You can adjust it here, but when the computer sees that it's wrong, it's going to adjust it back to where it needs to be. This helps the computer make accurate sets for different sawyers and different hydraulic situations where the hydraulics are hot or cold and different areas of the world that we sell these things in. Next is offset. This is how far the head rig will move up when you hit the offset switch. So let's say 625 thousandths is too much. I can go down with it, and I can just hold this and it'll scroll down to whatever value I want, or I can go up and hold it and it'll scroll back up to whatever value I want. Next is a height adjustment. After you get done with your scaling, which is preset at the factory, you can do a height adjustment if the head rig, if you go down and you cut a 1-inch board, but it's really 1/16, you need to tell the computer it's a 1/16 of an inch too high. So right now the height adjustment's at 0, it's in thousandths. That's 1/16 would be 62 thousandths. So I need to tell it to go down 62 thousandths. There it is. Now let's say it's 1/16 shy. I'd want it to add 62 thousandths. I've added a 1/16 to the height of the mill. Next is the scaling. This is where you tell the computer both ends of its travel, the bottom end and the top end, and you tell it what height it is at the bottom and what height it is at the top, and it figures all the points in between. So for scaling, just as it says here, it says for scaling, toggle adjust, and then there's enter code. This is to keep this from accidentally being changed. The code is simply adjust once and core 2 once. Scaling point 1 shows up. It says 1 inch here, so we want to position the saw at 1 inch. There it is. Now the computer and the saw say the same thing. We'll hit reference reset on the screen. So now we need to go Tools you'll need to change your computer is a 9/64 Allen wrench, a large flat screwdriver, and a small flat screwdriver. The computer's got 6 latches on it. We've already done them. Just go around and loosen them up. Let them hang to the side here. There's 2 on top, there's 2 on the sides. Now turn your computer off. Make sure your all stop is down for safety. Open your computer. It'll look similar to this inside. Simply pull this plug out here. Notice the red ribbon is to the left. So we'll hang this here where it won't get tore up. First thing we'll do, there's 3 quick disconnect plugs. And they have some small screws on them on each side. And I'm just loosening them so I can hear them click in there. I can kind of feel it too. That tells me they've reached the end of their threads. There's 2 on each quick disconnect. And I'm just kind of pressing in just slightly with my hands. That way when it hits the end of its threads, it'll pop just like that. Okay, now I'll carefully just pull out and kind of wiggle them a little bit. And pull out, don't pull them too far, you don't want to pull any wires out. There's 2 and 3. Now your computer is disconnected. Now there's 4 9/32 Allen heads holding it in place. Now behind here there's little white spacers holding this off of the metal of the Setworks box itself. They'll fall down, don't worry about it, the box should catch them. Now your old computer has been removed. Be in a box with a lot of pad foaming, but once you get to it, it should look just like this. There'll be a little sticker on it holding this envelope closed. Now, while you have your computer out, it's static sensitive, so you're going to be careful handling it. Before I take it out of this envelope, I'm going to come into contact with the metal of the saw. That way we're on the same electrical plane. Once I do that, I'm going to pull the computer out, set this aside. I'm not going to get far from the mill. I don't want to generate any static electricity that may damage this computer. The easiest way I found to do this is to take the 2 bottom screws and place them in, and then get 2 of my white spacers and hold them on the back as I put the computer in. So now that I have the 2 white spacers on the back, remember I want to stay plenty close to this mill. I don't want to get away from it and generate any static electricity. Hold the 2 spacers in place, slip underneath the fan, and as I line up the one in the lower right hand corner, I keep a little bit of pressure on the other one with my thumb. That way it holds that little white spacer in place. I'm just going to hand tighten it at first. My computer's sitting there. I usually like to go to this one in the upper right hand corner. Get my screw, kind of push the wires out of the way. Thread it, it's hanging out. Try not to put too much pressure on your computer. Putting the white spacer on the back. Now I can just move forward with it. Now you have your new computer in there. Tighten all the screws. And you don't want these too tight. Just barely snug them up where they won't vibrate loose, but they'll hold the computer securely in place. If you over tighten them, you'll break the circuit board. Now, once you have your new computer back in there, just take a quick disconnect, push them in firmly. Take your small screwdriver. Be careful not to over tighten, and go back around and tighten up the 2 screws on either side of each quick disconnect. Take the ribbon cable, and remember, put the red wire on the left. It goes right back in the top socket. It will not fit in any other socket. Once all that's complete, close your box, being careful to make sure that no wires get caught. Go around and tighten up all your latches. You'll have to start at one side and snug them up, and then because it's a big seal in behind here, you'll have to go back and forth several times to get the gasket, get even pressure on the gasket all the way around. That way the box will not leak. Once that's done, turn the computer back on. Your new computer comes pre-programmed with factory defaults. Go back into your programming mode. Go into scaling and reset your scale just as we showed you earlier. Now, one other thing you can do, if you do mess up on your scaling, while you're in scaling, you can, instead of 0.1 being a value, scroll down to 0. On 0.1, hit your reference reset switch just as you would if you were programming a scaling point. 0.2 will show up. It'll be 32 inches. It's a preset factory value. Just scroll on past it. And the computer's a cycle power now. This resets your computer to factory defaults. So now that the computer is at factory defaults, you have to go back into programming and go through your scaling setup. You should be ready to solve. The only tool you need to change out your transducer is a large screwdriver. Simply loosen the bottom 2 screws here. There's no need to take them all the way out. Just loosen them probably 2 or 3 turns. Get them loose enough where I can move this by hand. Now that I have it loose, undo this bolt up here. Quick disconnect. It should be finger tight only. There's a rubber gasket in there that keeps it tight, so there's no need to put pliers on or anything. Now that I've got it loose, I can wiggle it. And I've pulled it up and got it out of this bottom spacer. I can move it over. Slide it out. It'll only go in one way. So I'll start by sticking it through the top spacer and wiggling it up until I can clear the bottom one. And I usually put it towards flush with the bottom one here. Now I need to get this line in the center of this magnet. So I'll just rotate it towards the magnet. Now I'll simply retighten my screws. Be careful not to over tighten them. Now, I need to rotate this around until it just slips down in there a ways. And then I'll hand tighten the quick disconnect. And that's all there is to changing your transducer.
What would be a symptom if I hit offset and my head did not raise up?
You could have bad contact on your joystick.
Okay, what else would I look for if I feel the contacts correctly and everything? How would I double check and make sure I'm not replacing my computer over a failure of a wire or a joystick?
Well, the next thing you check is the wire, of course, all the way up. So you can simply open up your computer box, meter, about $12 at your local hardware store. It's good if you got a helper. Go ahead and open your Setworks box. All of the signals coming from set, offset, and reference reset are ground signals. So I've set my meter to measure ohms, or resistance. Now with the help of somebody else, set my meter up here where I can see it. I'm going to shut my computer off, pull this just to get it out of my way. I'll turn my computer back on. Now I've set the ohms. I'm going to put my ground to pin 8, which is ground on the Setworks computer. Then I'm going to go through. Here's where your 3 signals come in: set, offset, and reference reset. So hit set. Notice it goes down to 0 ohms. There's no resistance between that and ground. That means the wire and the contact is good all the way up here to the computer. Hit your reference reset switch. So I've checked my reference reset switch is over real close to 0 ohms, which is fine. Now last is offset. Go ahead and hold offset. 0 ohms. Now that tells me that the contacts and the wire all the way up here to the computer are still good. Now the coils that run your mill up and down are 12 volt coils. So I'm going to set my meter for 12 volts DC. Again, I'm going to put my ground wire on pin number 8. Now we're going to start out with set, which is pin 1.
Now, do I have a wiring diagram to show me this?
Yes, you do, in your owner's manual. Now, we have a helper here. We'll watch the meter here. I'll have him hit set. So go ahead and hit set. Or offset. Watch up here on the meter. Hit offset again. Now the meter jumps to 12 volts. It's telling you your computer's outputting 12 volts to the up coil on the hydraulic. Now next, pin 2 down. Go ahead and hit set. You can see the computer outputting 12 volts. Now go ahead and raise the head up and hit up reference reset. When you make a set, the computer uses a 2-speed valve to slow it down in the last half inch of your set. Let's check that now. Have your helper hit set. Notice when it got close, it jumped to 12 volts. It tells you right there that the computer is outputting and working fine. Now, the next place you can test is your computer feeds to the coils. each of these coils right here. Here's your up and down and your parachute valve. You can open up this panel right here. Need a large screwdriver.
Screwdriver, sir.
Thank you. There's two latches on this. Just loosen them up and let them hang to the side. Now, once you've opened the panel, let's stand right here. You can go through the same series of tests we just did, and you can check it all the way to right here. Put your negative lead of your meter right here, and here's your up signal, which will be offset. Here's your down, which will be set. Here's your 2-speed signal. All those are 12 volts DC. You can troubleshoot it all the way to the valve here. Also in here is guide in, guide out, debarker in, and your shutdown. These are all 12 volt signals here. You can have a helper. Be very careful not to get hurt in the machinery. You can have him guide in and out, and your debarker in, and you can check the signals. Now, the only way you get 12 volts out of the debarker is when it's in and working. When he turns it off, you shouldn't have 12 volts here. This shutdown is a ground signal. When it grounds out, the motor, everything on the mill should shut off. You should take your meter, set it to resistance, and check from here to here, and you should get 0 ohms.
So for my switches, does everything come through this panel first and then go to this panel?
No, your switches all come up to the terminal strip in the Setworks panel, and they either get a signal from the Setworks or they make a junction there, like your guide in and out, just make a junction on that terminal strip and then go to this box.
Okay, so if I was to check for my guide in and out, and if it's not working, I would check in this panel first.
Start there and then check there.
Thank you.
We're going to check our debarker signals and our guide in and out signals. Be sure that the motor is not running for safety. So I'm going to have a helper. We're going to check the debarker switch first. We're going to take the ground lug of my meter, which is set to 12 volts DC. Go to 8, which is always ground. Now pin 4 is your debarker out signal. So go ahead. And you see the meter rise to 12 volts. Now, your guide signal is next. The guide in and guide out is pin 7. You see it's working there. Now we can do the same check over here, but have our helper stay in the same place and check the wire all the way to the coil. I'm going to put my negative lead on the terminal strip marked negative from the battery. Guide in. I guide out. You see the meter rising. Now debarker. Now electrical check your mill all the way to the coil.
All of your main power supply comes from your battery. You have a black and a white wire which runs through over to your junction box and to your Setworks box.
There's the main fuse right here. It'll be an inline or blade type fuse. If you don't have any 12 volt power to right here, you need to check this fuse first.